Welcome to Talking Science, where we dive into the stories making headlines in the world of science and space. I'm Matt Miller. Brad's still swamped with work, so Thomas Crowe is beaming in once again. Tom, happy Tuesday.
Happy Tuesday to you too, Matt.
Let's get the headlines in this, the 45th week of 2021. Scientists have presented the largest number of gravitational wave detections to date. The Hubble team gets one science instrument running again as they continue troubleshooting the glitch. And Crew 2 returns as Crew 3 embarks on their 6-month stay in orbit.
This is Trek Zone's Talkin' Science.
Don't forget Trek Zone membership available via the join button under each video on YouTube or via the trek.zone/support. Plus, Trek Zone's on Twitter, Facebook, Instagram, and your favorite podcast feed. Find us, like, follow, and subscribe. Tom is on Twitter as well. Psycro, grab him there. Science writings as he does every week. Tom, some incredible things in the nighttime sky to be looking at. Jupiter, Saturn, and the Moon making a line as it appears to us. It's always fun to be checking out astronomical viewing through a telescope, binoculars, or anything else.
Yeah, I'm actually heading to Astrofest at Curtin this Saturday. So we're going to crack open the telescope and see what we can see up there.
Very, very cool. Looking forward to that. And unfortunately, I had to give away my telescope a couple of years ago, but certainly do enjoy getting out into the backyard and checking out the solar system as well. Let's get into the show. Leo Labs, who provide space situational awareness services to satellite and launch companies across the world, Tom, they've announced they are building a new radar site in Western Australia.
Yeah, just down in Bunbury, in fact, which is south of Perth. So it's an interesting one. Space situational awareness is looking at basically keeping track of your satellites. It can also be keeping track of space junk and micrometeorites, but we're also, one of the main reasons that it's used is to keep track of other countries and their potential sabotage or spying efforts. So it'll be very interesting to see how they go, because we already have a space situational awareness industry here. So it'll be interesting to see how this new player goes.
Well, Curtin University obviously has some impeccable timing and some pretty smart cookies. They're in our news again for the third week in a row. Researchers there have pinpointed the likely origin of Martian ejecta on Earth.
Yeah, so this was an interesting one. They basically found a whole bunch of meteorites that had landed on Earth about 1.1 million years ago, and then they used some machine learning and some surveys of Mars to see where it had come from originally. They backtraced the path of these meteorites, and so they found it came from a large volcanic region called the Tharsis region on Mars, and about 3 million years ago there was a lot of eruptions and they ended up here on Earth.
Well, Tom, a international team of scientists have released a paper teeming with gravitational wave detections. It's a treasure trove of data.
Yeah, so it's crazy how quickly this field has picked up. I think the first gravitational wave was just found in 2015, and now we've had 90 total, and 35 out of that 90 has come from the last couple years, from 2019 to the present day. They've just been ramping up. I think once they were able to prove that they could do it and that they got everything up and running, there's been a massive uptick. So it wouldn't surprise me if we kept finding a lot more as we progress.
Well, all of these new observations come from the second part of Observing Run 3, called O3b, which was an observing period that lasted from November 2019 to March 2020. In all, 35 new gravitational wave detections were found.
Yes. So 32 of them were actually from black hole mergers, so two black holes merging with each other. Another two were determined to be from neutron stars hitting a black hole, and there was a bit of a mystery one. There was one where they kind of calculated the mass of this second object hitting a black hole, and it was kind of in between a black hole and a neutron star. So the thought is it could be something like a miniature black hole, a supernova or something like that colliding with the star. I think the really incredible thing is we need things that are this big to be able to detect gravitational waves. We're talking about things that if they happened anywhere near us, it would just completely strip away our solar system. That'd be it. That'd be the end of existence. There'd be no trace. And we need them to be that big because gravitational waves are both so long and by the time they reach us, so faint. I mean, if you've ever seen LIGO, the place has these arms. It's like an L shape, this facility. And each of these arms is 4 kilometers long. And it's that long because they're just shining a laser from one end, from the base of the L up to the arm. And then they go back and forth 3 times to like fake it being a 12-kilometer path. And they need that because as the gravitational wave hits Earth, it's going to hit one of those arms first. And because a gravitational wave is basically a distortion in space-time, it's warping the fabric of reality, it's going to lengthen the path of this laser. And so it's going to be a slight time delay from the first laser and the second laser. And the way it works is, so normally when these lasers are running, their waves are kind of opposite each other, so they'll cancel each other out. When one wave is going up, like, a nice little ocean wave, if one's peaking, the other one's going down. And so as they add up together, it's going to be no light source. But if there's a distortion in space-time, the light source is going to take longer to go, so they're not going to be perfectly synced up anymore. And so that's when we get the detector going off. And because it's so faint, and it's such delicate equipment, if a truck is going along on a road 1 kilometer away, it's going to throw the whole thing off. So what they like to do is run a couple of these gravitational waves going at a time. So there's one, LIGO obviously in USA, Virgo in Italy, and CAGRA in Japan. And so they all check with each other. And once they do that, they've got a whole automated pipeline where once a gravitational wave hits, every observatory that can will stop what they're doing and immediately point to the point in the sky where something's happening, where they think something's happening, to see if they can get any light source or detect anything, to see if they can get any additional information. So it's basically a worldwide cooperation just to get these really faint signals that we're constantly hanging out for. Tremendous amount of work goes into it.
Yeah, it absolutely does. And just incredible as well that, it's an international collaboration to find these tiny little things happening out in the universe. And as you say, Tom, very glad that it doesn't happen in our nearby solar system or even our region, because that would spell disaster and it would be terrible, I think. But I don't think we'd probably wouldn't know because it'd just immediately happen.
Yeah, it would be probably, I imagine, quite quick and quite merciful. But I don't think, we're in a pretty stable area of the galaxy, so it's not like we're right slap bang in the center, which is where you expect a lot of these things. That's kind of why life was able to develop. If we were in a bad spot, we wouldn't be here today. So thankfully, we've got some prime real estate.
Exactly right. Well, the Hubble Space Telescope appears to be bouncing back from its latest glitch, Tom, with the team able to get the advanced camera for surveys operating again.
Yeah, so the Hubble telescope we've had for a long time. I think it got up and running in the early 90s, and it's really hitting the end of its life. It's due to be replaced by the James Webb telescope I think James Webb launches this December this year, so not long now. There was a malfunction with, so basically the communications within the satellite kind of went out of sync with each other. And because you're relying on data collection services from the instruments there, you want to make sure that everything's working in sync. It's all kind of nice, when it's not nice, they shut everything down into safe mode, which I guess would be a bit like, when you stuff up something on your computer and your computer doesn't like it, it'll jump into safe mode. Basically, it's trying to preserve the data and make sure nothing's going to go wrong with these instruments. There's 5 instruments on board the Hubble telescope. And so I think the reason there was an issue is just because it's getting towards the end of its lifespan, and I'm sure it's kind of dealing with a bit of legacy code, and even when it came out, there were issues with scientific instruments going awry and all these things. But it's been going for a long time, and credit to it. I think even once James Webb goes out, they're going to try and milk as much as they can.
Well, Dr. Brad and I have spoken a bit about glitches on Hubble a few times this year. This is another one, though, and it's still baffling the team. As you say, they're trying to find the root cause of those sync issues, and they're still under investigation. But hopefully, this isn't the end for Hubble, but she is dancing on the edge. We've had some incredible discoveries from her over the decades.
Yeah, I mean, I think at this point, it's basically a bit of human history. You want to keep it running for as long as possible for the scientific method, but you also want to take care of it as much as you can. So it'll be interesting to see when they do finally deorbit it, how that goes, if we end up getting Hubble, whatever's left of Hubble, stored in a museum somewhere. It'd be a lovely thing to go see. I think, it must be frustrating for them. It's not like you can just pop the hood and see what's going on.
Not anymore.
Everything is up there, and all the tools that you have to diagnose it are there. So you can't add an extra spanner. You can't go, add like a little scan or something like that. Everything is there. It's contained, and you just have to deal with the tools that you have available to you.
Yeah, exactly right. Well, lastly, this week, Tom, Crew 2 has returned home after a successful stint on the space station.
Yeah, kind of an inglorious return home. SpaceX has had a bit of a long-running issue with their toilets. Their Inspiration 4 had a tube disconnect in their toilet, and now this the shuttle that brought the Crew 2 home had the similar issue. It lines up with least space shuttle's flaws, which first I imagine would be a deeply unpleasant thing to be smelling, because it does evaporate in 2 days, but that's 2 days of like no real air circulation, just smelling the urine, dealing with it. So the reason it kind of went a bit awry is, these tubes basically suck all of the waste into like these nice little vacuum packed garbage bags to be burnt up. And I guess however they're installing their toilet, something's going wrong. Clearly this is a repeated issue. So yeah, basically knocked it out. And so all the astronauts had to wear adult diapers and just kind of deal with it for the 18 hours they had to land. So yeah, not a great return, but they got home safely, and I believe the Crew 3 is due to launch up into the space station today, probably in the next hour or two, right? It's very, very soon.
Yeah. Well, I was going to be sneaky here for people watching us in the future and say that it has blasted off as we record. I was going to do two alternate takes, and I should have probably mentioned that off air. But anyway, we can keep going with the show because the magic of television never gets broken. So they have either blasted off into orbit or they have been delayed again. If they have been delayed again, it's another delay. But if not, they'll be docking tomorrow for their extended stay on the space station.
Yeah, and I mean, it has had multiple delays. We had the weather delay to begin with, and then we had the health issue, and then it was delayed again because NASA just wanted to, I suppose from their end, they were having toilet issues. There was all these other issues going on. They just wanted to make sure Space Crew 2 got home safe and sound before they sent something up, which is not how they normally do it. Normally they like to have the crew go up and then have the others return down. But just, you can have all the scientific instruments in the world, you can spend millions of dollars, and you're still at the vagaries of fortune,
Exactly right. Yeah, absolutely. Well, just before we go, Tom, a look ahead to this week's Talkin' Science interview. Dr. Danny Price beamed in earlier this week to dive into the Proxima Centauri signal that we spoke about last week. What was first thought to have been detected by Muriang in 2019?
Well, we did some observations of Proxima Centauri, which is our nearest stellar neighbour at about 4.2 light years away. We're using the Parkes Muriang telescope, and we sat on that data for a while because there was other stuff we were doing. We were looking for solar flares and doing a big multi-wavelength campaign with lots of different telescopes. But we set a portion of that data aside, the SETI data aside, to look for technosignatures, which are any signal that doesn't appear to be natural in nature and coming from outer space. And in 2020, my summer student, Shane Smith, went through that data and found something interesting. And it wasn't until December 2020 when the news kind of broke and the cat got out of the bag that we had found something interesting.
Well, that interview is available now, so click the card to beam over and catch it. Tom, it's great to pick apart the stories of the week with you, and we'll do it again real soon. Dr. Brad says he'll be back next week.
Great. Thanks for having me.